We continue Unit 12, Rational Expressions, with adding and subtracting. Example 1. We need to get an LCD so that we can add these two expressions together. The first thing is to factor the denominators completely. 6x will factor to be 2 times 3 times x. 3x is already factored. Write down the first expression, 3x. Looking at the second expression, start with the 2. Is there a 2 in this expression that I wrote down? No. So I need to multiply that by 3. Move to the second number, which is a 3. There already is a 3, so I do not need to write it down. Move to the x. There already is an x here, so I do not write it down. So my least common denominator is 6x. So we write 6x down and we draw one division line above it. What do I need to multiply by the 3x to make it 6x? Well, that is 2. If I multiply top and bottom by 2, I will get 6x in the denominator. Next number. What do I need to multiply the 6x by to get 6x? Well, if I multiply both top and bottom by 1, that does the trick. Simplify, we get 4 plus 5 over 6x. That is 9 over 6x. And we can still reduce. 3 goes into 9 3 times. 3 goes into 6x 2x times. And this is my answer. Example 2. We need to get a common denominator. So the first thing I want to do is factor out my expressions in the denominators. I have 5, 2 x's, and 1 y. In the second denominator, that's 5 times y times y. Write down the first expression. Look at the second expression. Start with the 5. Is there a 5 in this expression? And yes, there is. So I do not write that down. Let's go to the next number or variable. And it is a 5 again. In this expression, I've already used this 5. There's not another 5 for me to use, so I need to multiply by 5. Go to the next term, y. There is a y in this expression, so I do not write it down again. Go to the next one. There is a y here, but there's not a y down here, so I need to multiply by y. Our LCD is 25x squared y squared. So we want to write this down with a big division line across the top of it. Starting with the first fraction, what do I need in this new denominator to make it look like the new denominator? Well, I need a y squared here, and I need 25. So if I multiply both top and bottom by 5y, that will get me 25x squared y squared. Now we look at the next denominator. And I am missing an x squared. So if I multiply both top and bottom by x squared, that will take care of what is missing. Now we multiply this together, and we get 15y minus 18x cubed all over 25x squared y squared. I can still take out the greatest common factor. There is a 3 in common with the 15 and the 18. And that leaves 5y minus 6 x cubed. And this is my answer. Example 3. We can see that both of these expressions cannot be factored any further, and my LCD is x plus 2 times x minus 2. So write that expression down in the denominator with one big line. Now what do I need to do to x plus 2 to make it look like this? What do I need to do to x plus 2 to make it look like this denominator? Well, we can multiply both top and bottom by x minus 2. So I will multiply 3 times x minus 2. Now I'll look at this denominator. What do I need to multiply the x minus 2 by to get x minus 2 times x plus 2? X plus 2. At this point, I need to distribute and simplify. The 3x gives me 3x. 3 times negative 2 gives negative 6. Negative 8 times x, negative 8x, and negative 8 times 2 is negative 16. And all of this is over x plus 2 times x minus 2. Now we combine like terms. Still need to check to see if these can be factored and reduced any further, and 5 will not go into 22, so I cannot pull anything out. So this is my answer. Example 4. We can clearly see that the least common denominator is x minus 1 times 2x plus 1. So write that expression in the denominator with a line over it. Now what do I need to make my old denominators look right? In the first rational expression, I need to multiply both top and bottom by 2x plus 1 because that is what is missing. In the second rational expression, I need to multiply both top and bottom by x minus 1. That is what is missing. Rewrite our expression with the new numerator. Now we have to distribute. And this is all over our new denominator. Now we collect and combine like terms. See, I have a 2x squared and an x squared. This will give me 3x squared. We have a 1x and a 4x, which is 5x, a negative x, which is 4x, minus 3x, which is just x. Or you can look at it as in the x's will cancel, and then 4 minus 3 is still 1x. Combining the number terms, I have 2 and 3, which gives 5. I have 3x squared plus x plus 5 over x minus 1 times 2x plus 1. I'm done as soon as I can figure out if I've completely factored or not. A target product of 15 to get a sum of 1, and there's not one. So this is my answer. Example 5. In example 5, I need to be careful. This right here is a difference of two squares, and I want to make sure that I have every piece in my denominator. My least common denominator will be x plus 3 and x minus 3. And I need to see what each piece is missing. In the first expression, there's nothing missing, so I just need to write down 8x. In the second expression, the x minus 3, I still need an x plus 3. So I need to write down x minus 7 times x plus 3 because that is the missing piece of the information on this side. Now I need to distribute and multiply. 8x stays right there. X times x squared is plus x squared. X times 3 is 3x. Negative 7 times x is negative 7x. And negative 7 times 3 is negative 21. Combine like terms and simplify. I have 1x squared, I have 8x, 3x, and negative 7x, and a 21. So x squared is by itself. Eight x plus 3x is 11x, minus 7x is 4x. Minus 21. All of this is over x plus 3 times x minus 3. I'm still not done. I need to check and see if that is all there is to this problem. Looks like this top number will factor. The two numbers that multiply together to give me that are 7 and negative 3. So rewrite that as my factor, x plus 7, x minus 3, and this will give me something that will reduce even further. At this point, we know that the x minus 3 will reduce with the x minus 3 on top, and my answer is x plus 7 over x plus 3. This concludes this flap of our foldable.